From the dawn of humanity, we've looked to the stars with wonder and curiosity. Today, we're on the brink of making science fiction a reality as we prepare for the colonization of Mars. But what does it really take to make the red planet our second home? Let's dive into the challenges, innovations, and ethical dilemmas of this monumental endeavor. Mars has captivated our imagination for decades. Its polar ice caps, large valleys, and the prospect of liquid water beneath its surface make it seem almost Earth-like. But don't be fooled. Mars is a cold, radioactive desert. Its ground is toxic, filled with perchlorate salts, and its atmosphere is so thin that it can cause your blood to boil. Imagine living in a place where breathing is impossible, and the sunlight is often obscured by enormous dust storms. Welcome to Mars. Surviving on Mars would require overcoming monumental technological and ethical challenges. So, let's break it down. Before we even think about living on Mars, we need to solve the energy problem. Mars is energy poor, with solar power being only 40% as effective as on Earth, and enormous dust storms can obscure sunlight for days. Given the inefficiency of solar and wind power, nuclear technology might be our only option initially. But even that comes with challenges. The nuclear fuel and the reactor would have to come from Earth, at least for the first few years. Creating a semi-permanent outpost on Mars is a monumental task. The pioneers will face intensely stressful lives, filled with challenges never encountered before on Earth. Mars's atmosphere is only 1% as dense as Earth's, and mostly made up of CO2. Habitats need to be pressurized and filled with an artificial atmosphere made of nitrogen and oxygen. Without an extensive magnetosphere or a dense atmosphere, harmful radiation from space reaches the ground. A person on the surface would be subjected to 50 times the radiation that they would be on Earth. 3 years on the surface of Mars exceeds the radiation dose limits imposed on NASA astronauts for their entire careers. Habitats could be shielded with a thick layer of frozen CO2 and a meter of dirt, but this means living in windowless tunnels. One of the less talked about but significant challenges is the toxic perchlorate salts in Martian soil. Constant exposure could be deadly, requiring innovative solutions like specialized spacesuits that never enter the base. Survival isn't just about air and shelter, it's also about food and water. Mars does offer some hope in this regard, especially near its poles, which contain thick layers of ice. Extracting water from Martian soil or icy deposits is a crucial first step, but this isn't as simple as drilling a hole. The water needs to be purified and made safe for human consumption. Growing food on Mars is another hurdle. The soil lacks vital nitrogen compounds and is contaminated with toxic perchlorates. Before we can grow anything, we'll have to detoxify the soil, a process that is both time-consuming and energy-intensive. Aquaponics could be a solution for more varied and tasty diets. This system allows us to raise fish and plants together, recycling nutrients between them. It's an important psychological boost for our overworked pioneers. Low gravity, radiation, and isolation. These are just a few of the health challenges that Mars settlers will face. Mars has only 38% of Earth's gravity, which could lead to muscle wasting, bone loss, and cardiovascular problems. Rigorous exercise regimes and potentially rotating habitats offer some mitigation, but they're not perfect. Imagine being stuck indoors, in tight spaces without windows, disconnected from nature with the same people, performing the same routines day in, day out. The psychological toll could be immense. NASA and other space agencies are researching countermeasures against these challenges, but astronauts should be intensely screened for mental resilience. SpaceX's Starship and NASA's research into nuclear thermal propulsion are just the tip of the iceberg. Mars could also be a real-world testing ground for semi-autonomous AI, given the communication delays between Earth and Mars. AI robots will likely prepare the Martian landscape for human habitation. These robots will be semi-autonomous due to the communication delays, making AI a critical component of early colonization efforts. It could also play a crucial role in resource extraction. making the colony more self-sufficient and reducing the need for human labor in dangerous or repetitive tasks. Colonizing Mars isn't just a scientific endeavor, it's also an economic and social challenge. How will this colony sustain itself economically? What kind of society will it build? Resource extraction and other potential industries could make the Mars colony economically viable. However, if AI proves effective, the need for human labor might be minimal, raising questions about the colony's economic structure. People might move to Mars to escape earthly issues, but they'll bring their own social and cultural dynamics with them. The risks and uncertainties involved in surviving in a harsh and unfamiliar environment could shape a unique Martian society. Not everyone is optimistic about Mars colonization. Critics argue that the harsh environmental conditions, including the thin atmosphere that could cause bodily fluids like blood to boil, make it an unfeasible goal for the foreseeable future. Given the severe health risks, some argue that attempting to reproduce on Mars would be ethically questionable. The psychological toll of living in artificial enclosed habitats could also lead to mental health issues. Pioneering astronautics engineer Louis Friedman compared the enthusiasm about Mars colonization to unfulfilled promises from the 1940s and 1950s about ocean and Antarctic colonies. Are we setting ourselves up for disappointment? The journey to colonize Mars is more than a technological endeavor. It's a test of human resilience and ingenuity. As we innovate and collaborate to overcome the formidable challenges ahead, we're not just aiming to make Mars our second home, we're also redefining what it means to be human. This quest prompts us to look both outward to the stars and inward at ourselves, asking not just how we'll reach Mars, but why we aspire to go and what kind of society we aim to build there. Thank you for joining us on this journey through the challenges and possibilities of Mars colonization. If you found this video informative and intriguing, don't forget to like, subscribe, and hit that notification bell for more content like this. Until next time.